now we will learn the different phases of VLSI design flow, right? So there is something called as a design flow, which are basically the steps involved in designing the VLSI circuit. Okay, and it is very important that we have to understand all those steps, then only we'll be able to begin our design, right? So the design actually starts from something called as the specifications or the idea. Let us say you're going to design a VLSI circuit, right? For that you need some idea, right? What kind of circuit you're going to design, and you need a basic specification of the system, the VLSI chip. Let's say you're going to design a microprocessor, that is again an VLSI device, right? Microprocessor has billions of transistors integrated into a single chip, and that becomes your microprocessor, and that is used in your mobile phones. Okay, so it is very important to understand the specifications of that particular chip. What is the requirements, and that have to be understood. So that is the first thing, that is understanding and making a ground survey on that. Moving on, we have the second step, which is nothing but the architectural design, and we are at a very high level of abstraction. Okay, and we actually don't know the inner details now. Let us assume like that we don't know the inner details. We are just designing the architecture. The architecture means how many transistors it can contain, and what kind of actually we don't know how many transistors it can contain at this particular level, which is the architectural design level, where we know only about the architecture. Okay, we don't know how many transistors we are going to use, and we don't know the logic circuits we are going to use. We don't know anything. We know only the architecture, which means what are the blocks, the modules inside it. That's it. Okay, the block. Okay, let us say we have a microprocessor like this. What are the blocks inside it? Okay, sub modules inside it. That is what we will know in this architectural design. Moving on, we have something called as a logic design. Okay, where we have to design the logic. That is, in architectural design, we will be able to know how many blocks are there inside this chip. That is, each block will do a particular purpose, right? For example, this block, let us say this is a combinational circuit, let us say it is an adder, let us say this is a flip-flop, let us say this is a latch, like that. Okay, and we have to design the logic of these blocks in the logic design part. You know the logic, right? For adder, you know the logic, sum equal to A XOR B XOR C. Okay, it is very important to have a grasp on the digital electronics to understand this VLSI design. Okay, only if you understood digital electronics very well, you will be able to understand this subject also. So logic design, right? So logic design is where you know the logic of all the blocks, right? And moving on, we have something called as the circuit design, or I could say, yeah, circuit design. Circuit design is where you design this adder or flip-flop or latch. Okay, so you know all the submodules now, you know the logic of them after the logic design. Now we are going to design them using circuits. That means I know the adder equation, right? I know the adder equation. What is the adder equation? Sum equal to A XOR B XOR carry in. Okay, and carry out will be equal to A and B, or B and C, or C and A. These are two simple basic AND equation which you might have adder equations which you might have studied already in your digital electronics, right? A very preliminary course. Okay, so we have to design circuits for these functions. So designing these functions will come under logic design. You know the logic now, and you have to actually design the circuit. That is, you have to put XOR gates and everything using transistors in circuit design. So this is the most crucial part. We are going to design the logic using circuits, right? We are going to implement the logic using transistors. That is what circuit design means. That is, implementing logic using transistors. Implementing the logic, that is, here it is an XOR logic, here it is an AND plus OR logic. Whatever logic it may be, we have to implement using transistors, and that comes under circuit design, right? And that is what we are going to concentrate. Then we will be moving on to something called as physical design. So after you have made your transistors, that is embedding them, that is integrating them on a single chip, will come under physical design. That will also be done. And moving on, we have the fabrication part. Fabrication is something like manufacturing. So after you have done your physical design, you are good to go. You can manufacture your chip. That is done by the fabrication stage. Then after that, you have to test your chip whether it works or perfectly or not. Before that, you have to pack them. So that is packaging step, a very straightforward step, and you have to test them. So Among all these steps, we are going to focus on architectural design, logic design, and circuit design. So these are the three important steps that we will be focusing in this course, right? Architectural design, logic design, and circuit design. Understand that architectural design means you are at a very high level of abstraction where you only know the modules. Logic design means you know the logic, that is the equation of all those sub modules. Circuit design is where you implement that equation using transistor circuits, right? Okay, so these are the very crucial steps in designing a VLSI chip. Okay, I hope you understood this. Thanks a lot.